Hello everyone, today I would like to take some time out of that crazy launch schedule we're in right now to talk about the different software projects we've been working on for the past few months here at EOS Canada. In this video, I'm going to cover a few things starting with the EOS Go library, then I'm going to go and explore EOS BIOS, which is the first tool we built using that library, which allows you to create and scaffold a local blockchain that is very similar to mainnet for development purposes. Then I'm going to talk a little bit about May 5th meetup that we organized where we interacted with the blockchain using EOS Go and demonstrated an employee rewards program. So you can take a look at that later. And then we're going to show quickly EOS C, which is a small Swiss knife tool that we built using the EOS Go library. And finally, I'm going to just show off an unreleased piece of software which is used to sign blocks using the feature that was recently introduced in EOS.io to have an out-of-band signing of the blocks, which is a very important security feature. I want to talk first and foremost about the EOS Go library. So it's a Go library. It is the basis for most of the other tools we're going to present today. And it's a fully fledged library that handles like interacting with the API endpoints. It handles interacting with the peer-to-peer protocol. It knows how to marshal and unmarshal all the messages. It also knows how to do signature, just like the EOS.js library. It also knows how to sign blocks just recently when we got that out-of-band signature protocol from Block One. It also has support for proxying the EOS Go library is built in Go, of course. And why Go? I think I love Go a lot for many reasons, and here are a few. So Go allows you to have a single binary output with 0 dependencies. So you can take that binary and copy it anywhere, and it doesn't even need libc. You can drop it in a Docker image that has 0 bytes, and it will run there. It can be compiled cross-platform, Windows, Mac, Linux, Raspberry Pi, ARM, Android, iOS. Like all the targets are, like there's a lot of targets. And you have one code base and it compiles blazingly fast. It compiles like a medium-sized project in under 2 seconds, right? So the iteration, the flow of iteration, sometimes you compile your program faster than you would start the Python interpreter, for example. So you get the proficiency of Python with Go because it's fast and the tooling is awesome, but you get a lot more performance because it's compiled down to binary code, right, on each platform. There's no VM in between. And also you don't have a GIL like you have in Python. You have great primitives for concurrency, so it makes a lot of sense for network services. And also you get near the speed of C++, plus a few bells and whistles, to simplify and have no risks of buffer overflow because all memory is managed and garbage collected, which takes a little hit on performance, but you get a lot of safety from there. So all in all, it's a great systems programming language. And let me be clear, it is not a programming language in which you can write contracts today. Okay, the runtime for Go brings in a lot of things that you don't want in a smart contract. You don't want to manage concurrency in a smart contract, right? So for that today, C++ and maybe some other options are, I think, the best option for building smart contracts. And they're, especially since the code base is C++, you can reuse a lot of things from EOS software to build contracts. But EOS Go, I think, is a great option for building tools around that will interact with blockchains and serve potentially like a big farm of servers that will connect to the blockchain behind the scenes. Right? So now let's talk about EOS BIOS. EOS BIOS is a tool I wrote when I saw that there was no injection tool. There was no tool to inject all the transaction in a clean blockchain, an empty blockchain, so that it was filled with all the system contracts, the snapshot from mainnet from ERC20 crowd sale, and the different other things we need to have a working blockchain in which you can create new contracts, provision accounts, and do all the operations you would need and that are offered by the mainnet eventually. So my goal was to build EOS BIOS so that developers like some of you guys there can have a single command to run, and it will provision and populate your local blockchain with a clone of mainnet. So take a look at this here. This is EOS BIOS, and this here is the configuration for mainnet. And the boot sequence here reflects all the steps we need to have a blockchain just like mainnet, right? And then you can come on your own laptop and punch in EOS BIOS boot single, and this will, through Docker, It'll download an image, it'll start the image, it'll do the injection, and drop you with a fully fledged blockchain just like mainnet. So it's available on our GitHub, github.com, EOS Canada /EOS BIOS. Make sure you get a trusted version. We do have binary releases over there. The next thing I wanted to talk about is the May 5th meeting we had. It's a meetup we had here in Montreal where we covered using the EOS Go library to interface with a smart contract that we built for that event. It's an employee rewards program, just like Shopify's unicorn system, and allows you to vouch for people, say, hey, high five for doing this, high five for doing that, and then the votes come in, and then you can reward your employees based on the good work they've done and the work that people have recognized. So that's all on EOS blockchain, and we wrote a small command line tool for you to cast votes and post, a high five to your peers. And all of that is using EOS Go. It's an hour and a half long video. I invite you to go and see that. It's all on our GitHub there. It gives a great in-depth view of how to use EOS Go in a concrete example. The next tool I want to present is called EOS C. EOS C is a cross-platform command line tool, similar to Kleos. It might remind you something from the past. We took the name because it's a simple EOS command line tool. The goal is to make it sort of a Swiss knife, and today there's a few features that are very important, especially for unlocking the chain at first, because it has a built-in vault, so similar to KaosD, and also a voting tool. So you can use that to create a local wallet. It's a wallet format we're going to build on, and it's going to be retro compatible, so it's safe today to use that. It has strong cryptography. All the cryptography primitives are listed in there. And so using the vault command, you can create a new wallet, and using a passphrase, you can encrypt that locally into a simple JSON file, which you can back up, and it'll give you public keys that match the private keys inside. And you can also import keys from some other place that you might have created earlier, and then you can vote. You can call EOS vote for producers, and it's going to use the keys built in. So you can read the wallet and also cast a vote. You don't need to have two separate tools. You don't need to have them communicate together. It's a single thing, and it's cross-platform. So I think it's the only command line tool you can use on Windows today, as Kleos is first difficult to build with a C++ toolchain, but also does not build on Windows. If you look at the help here, we see that there's a few commands, a few tools for block producers. You can get the chain information just like get info on Kleos, and there's a vault there and vote. If we look at vault options, so with serve here, it allows you to listen on an HTTP port and serve requests, and it's a drop-in replacement for KaosD, the standard distributions key management service. The base tool also have vote, EOSC vote. You can vote for producers and a proxy, and we kept this release particularly simple. There's a host of other tools we didn't put in for this release so that people who want to unlock the chain are not confused by other things that are not meaningful to them. And there's also a few things for block producers here. If you run the EOSCBP command, you'll see you can register, or chain freeze is the features to allow synchronizing a chain and stopping it at a certain place so you can have a controlled replay of your chain. So these are all tools we're building in there that we can iterate fast, have them cross-platform, and for people to easily build upon also. The last piece of software I wanted to talk about is one I think is very important to this ecosystem at this point. Is a security tool. It's called EOS Block Signer. You can get it soon because it's not released yet. It is under test right now. I want to make sure it works well before we send that out. It's also based on our EOS Go library, and it allows you to sign blocks. So this is destined to block producers. Block producers now have an option in the Node.EOS software to have blocks signed either with the private key that is passed in the configuration, but there's a security risk I'm going to explain right now, or we can have it signed by another process. And this is the process that we built here. We made it so you can reuse a vault created with EOSC Vault, but also we added the feature that you could wrap your private key into a KMS, so the key management service from Google right now. There's a plugin that we wrote right now for Google. We could have a plugin for Amazon and other key management services to encrypt your private key with those services. So the private key would never be written on disk on these machines, and it would be paired with your Node.EOS, so the block signing would be out of process. Now, this is to mitigate a risk. You know, when you're running a piece of software that uses a WASM virtual machine, which can run any code, and moreover untrusted code from people, because it's a blockchain. People like send code to the blockchain and it's executed in that very process where the private key is. If it ever was able to burst out of that sandbox and execute arbitrary code, it would be able to get to the memory location of the private key. And with some methods, I don't know, maybe possibly, they could exfiltrate that key out of the process and send it back to an attacker. If that would happen, then that would mean that all block producers would be owned at the very same moment, like by exploiting the same bug exactly at the same time. So by having an out-of-band signature, the payload that would try to steal your private key would need to have a harder time to get them, right? Especially if those keys are in memory in another process, potentially on another machine, it would make it very difficult to grab and to own the whole network at the same time. So Block Center, we're putting that in our infrastructure right now. I think it's a great little tool. It's under review, and we're going to send it out to you guys as soon as possible. So these just are just a few of our tools. We have many other tools planned. Our dev team is working on some other funky things for exploring data, for whatever. And we hope that open source contribution is useful to everyone and it can be widely distributed. We're really proud of the work that's been done right now by the whole team and a few other outside contributions too, and for other folks who have reviewed. I thank you all. If you have any other questions, join our Telegram channel, send out issues on GitHub, or contact us, whatever the other means. Have some great time over there, and let's talk later.